All right. Welcome back. So this is the Activity 3 review. It has the Captain America shield on it. So we're going to go through the guided practice on this. It should only be one page. This should be a lot shorter than the previous video that had the, for the Batman packet. So let's go ahead and jump right in. So Activity 3 was all inequalities. It's the exact same steps as solving equations. We have a few things we have to watch out for with inequalities, but other than that, it's the exact same steps. You are welcome to use a do and undo list in this if it's helpful to you. I probably will not do it through here. I'm just going to kind of go through it quickly because my kids have always told me that I spend too much time in these videos and they take too long, so I'm going to go through it kind of quickly. Alright, so let's just go ahead and jump right in. Okay, so we're going to solve these just like normal. We are multiplying x by 2 and subtracting 3. So to cancel that, we'll add 3 to each side. And that cancels. We have 2x is greater than 10. We'll divide both sides by 2. And x is greater than 5. So same steps, just got an inequality symbol. Okay. What we're also going to do is we're going to graph our solutions. So what I typically do is I typically put 3 numbers on a graph. For these, when we get to compound inequalities, I'll put more. I put my target number that I'm comparing in the middle. Do one number less, one number more. And then we have some rules real quick. We indicate whether or not 5 can actually be a solution by the way we circle it. So we're going to put a circle on 5 because that's our target. That's our target number. We're determining if x is greater than, less than, or equal to this number. So this is just x is greater than 5. It means we can't, 5 is not greater than 5. So we can't include 5 in our answer. So we're going to leave this circle open. We're not going to color it in. And then because x can be greater than, it can be everything greater than 5. So it can be 6, 7, 8. It could be even 5.00001. Just anything greater than 5. Alright, so we have it solved. We have it graphed. Alright, B. Again, we have m. It's being divided by 3, and then we're adding 1. So we'll subtract 1 to cancel. So we have m divided by 3 is less than or equal to 6. And then we'll multiply each side by 3. These will cancel, and we have m is less than or equal to 18. Right? No, it's not. I'm sorry. I told y'all I was going to mess something up. I didn't actually subtract my 1. This is m divided by 3 is less than or equal to 5. 6 minus 1 is 5, not 6. We'll multiply both sides by 3. M is less than or equal to 15. Okay, and then when we graph this, we have 14, 15, and 16. We'll put our circle on our target number, which is 15. We're going to color it in because m is less than or equal to 15. So 15 is in our solution set. So we're going to color that in. It's going to be a closed circle. And since m can be 15 or less, we're going to indicate all the values that are less than 15. So, yeah, sorry about that. Ooh, excuse me. Okay, keep going. We're going to subtract 9 from each side. P divided by negative 8 is greater than 4. Let's cancel out division. We're going to multiply both sides by negative 8. And we have P, and we have 4 times negative 8 is negative 32. Now, when you multiply or divide by a negative, it flips your inequality sign because it changes the signs on both sides of your on both sides of your inequality. So if you had like x is less than negative 2, well, then negative x would have to be greater than positive 2. Like, if you would have to switch the inequality sign to indicate that you also switch the positive and negative signs. So yeah, so it makes your inequality untrue if you don't swap them. Okay, so now we're going to graph. We have negative 33, negative 32, negative 31. You're going to put an open circle on 32. There's no equal to bar, so open circle. And P is less than, so we're going to go to the left. We're going to go to everything less than. So remember, our negatives are kind of in backwards order. And 33, negative 33 is less than negative 32. It's more negative, so it's a lesser value. It's like saying who has more money, the person that owes $5 or the person who owes $10. Well, you know, neither one of them have any money, but at least the one with $5 is in less debt. So, smaller number is greater in that instance, which seems weird. Okay. Alright, so, D. Let's see. I think what I would do, let's divide both sides by 3. These will cancel. 6 divided by 3 is 2, so we have 2 times L plus 3 is greater than or equal, less than or equal to 2L plus 6. And then let's distribute this 2. And we have 2L plus 6 is less than or equal to 2L plus 6. So if we look at this, we have 2 of the same thing on each side. So we have something is less than or equal to itself. That's always true. It will always, something is always going to be equal to itself. So even though the less than sign's there, whatever we plug in for L, it's always going to be less than or equal to itself. So this is going to have infinitely many solutions. Infinitely many solutions. As far as graphing this goes, and also you could say L is equal to all real numbers. I'm not sure that you actually would graph this, but let's just, for fun, it's all real numbers. It's everything. We could even go, you can be a little bit of a smart aleck and go from negative infinity to positive infinity and go forever. So there we go. We could do that too. There's no circle or anything because it's all solutions. It's all real numbers. So we can say infinitely many solutions, or L could be all real numbers. Okay. Alright, E. So this is kind of funky because you have 2 inequality symbols. What this means is that the expression in the middle is greater than negative 12 but less than 18. It's somewhere in between these 2 values. So when we solve this, we're going to actually solve, we're going to treat this as one equation, and we're going to treat this as we're going to treat these as 2 separate inequalities, but we're going to work them at the same time. Alright, so first things first, you could multiply to get rid of the fraction, but this is 1/2 and we have 2 even numbers, so let's make all of our numbers smaller. We have negative 12 is less than half of 4 is 2, so 2x. Half of 16 is 8. So I have 2x plus 8. I have negative 12 is less than 2x plus 8, which is less than 18. Okay, so if we were just solving this, we would subtract 8 from both sides. If we were just solving this, we'd subtract 8 for both sides. Sorry, can't write. There we go. So I'm just going to subtract 8 from all 3 sides. And 3 sides sounds weird, but we're going to subtract 8 from all three expressions, maybe is more correct. All right, so negative 12 minus 8 is negative 20. These cancel, we're left with 2x. 18 minus 8 is 10. We're going to divide all sides by 2. Negative 20 divided by 2 is negative 10. 2 divided by 2 cancels, we're left with x. 10 divided by 2 is 5. So this tells me that x is somewhere between negative 10 and positive 5. So it's greater than negative 10, but less than 5. Okay. Okay, that works. Okay. So, we're going to put two open circles, one on negative 10, one on 5. It's greater than negative 10, so it goes this way. It's less than 5, so it goes this way. So we're just going to connect from from circle to circle. Okay. All right, F. We have 2r plus 3 is less than 7, or negative r plus 9 is less than or equal to 2. So this is an or statement, which means that it's not something that's going to be connected like this. My two inequalities should split apart. It's either going to be something on the left or something on the right. It's going to be this or that. Can't be both at the same time. Okay, so we have 2r plus 3 is less than 7. So we're going to treat these are two separate inequalities. We're going to solve them separately. So let's subtract 3 from each side. 2r is less than 4. We'll divide both sides by 2. R is less than 2. Okay, so we're going to go to the other side. We're going to subtract 9 from each side. We have negative r is less than or equal to 2 minus 9 is 7. We don't want to know what negative r is. We want to know what r is. So we're going to cancel out the negative. We're going to divide by negative 1. And remember, when you divide or multiply by negative, it flips your inequality. So r is greater than or equal to negative 7. We're going to graph that to the side. I lied. 2 minus 9 is negative 7. When we divide by negative, this is going to be positive 7. Sorry. Okay, so r is either less than 2, so we're going to have an open circle on 2 going to the left, or greater than 7. Greater than or equal to 7, so we're going to have a closed circle. Okay, so we should be good here. So we have our final answer is r is less than 2, or r is greater than or equal to 7. Alright, G, the sum of any two sides of a triangle must be greater than the length of the third side. Okay, so what that means is that if I take two sides of a triangle and add them, this should be greater than the length of the third side. Same here, if I take these two and add them, it should be greater than this length. If you take these two and add them, it should be greater than this length. If you have two sides of a triangle that are not greater than the third side, it ends up collapsing. Like, so you have your bottom side. If this side and this side are not greater than that total side, they're going to fold in on itself. And it's not going to make a triangle. That's the hinge theorem in geometry. So when y'all get to geometry next year, you can be like, ooh, I already know what hinge theorem is. Okay. So we're going to, we have a couple of things to notice. We know that these two sides added together have to be greater than this. Right? Yes. So 6 plus 11 has to be greater than x. I had to think about that. Okay. Then this side and this side has to be greater than this side. So 6 plus x has to be greater than 11. And this side have to be greater than this side. So 11 plus x has to be greater than 6. So let's look at this last one real quick. 11 plus x must be greater than 6. The only way to make this not greater than 6 is if x is negative. And you're not going to have a negative side length. That also does not make sense. So this one, because 11 is already greater than 6, I think we're good. Okay, so 6 plus 11 must be greater than x. Well, what's 6 plus 11? 17. So x has to be less than 17. If it's greater than 17, then these two will collapse and it won't make a triangle. Okay, 6 plus x has to be greater than 11. So if I subtract 6 from each side, you get x is greater than 5. So we know that x has to be greater than 5. But x can't be bigger than 17. Which means that x has to be somewhere between 5 and 17. Also can't equal these because then, again, the triangle will collapse upon itself and make a straight line. So it doesn't work. So it has to be greater. Alright, so here's my final answer. X is between 5 and 17. And then when we go to graph it, 1, 2, 3, 4, 5, 6, 7. Let's see. Let's do 2, 4, 6, 8, 10, 12, 14. I didn't do enough. 16 and 18. Okay. I should have started at like 4. Okay, so when we graph these, you notice I went by 2's. So 5 is in between 4 and 6. 17 is between 16 and 18. So, and then we'll connect those. Alright, so this one was a lot shorter. I hope this was helpful. If you have any questions, feel free to email me or your current teacher. Have a good evening.